Okay, welcome everybody. I think it's 6:30, so we can start. Today we are here with Bahriye İlhan Jones. She is an assistant professor in Istanbul Technical University, Department of Architecture. She received her bachelor, master's, and PhD degrees from Istanbul Technical University. She also worked as visiting researcher in University of Salford, Liverpool John Moores University, United States Georgia Institute of Technology, and also Technical University of Munich. She works in the field of project management, and her expertise is on the applications of BIM, which is an acronym for Building Information Modeling. I invited Dr. Bahriye İlhan Jones here today because project management is a crucial subject in construction. It's also a very popular graduate degree choice because it has very strong ties with the industry. Architects who specialize in this area can have very good professional careers. Unfortunately, we do not have much time to cover it in our classes. So I asked her to make an introduction for us. Today, I will be acting as a moderator and piling your questions and later asking them. So you can write your questions on the chat box whenever you want. Okay? So welcome and thank you for joining us today, Dr. İlhan Jones. What would you like to share with us today?
Hello everyone, thank you very much for the introduction, and I also would like to thank you for inviting. I'm really happy to be here and talk about project management and BIM. So let's share my screen. And today we are going to talk about project management, general concepts, what are the project management processes, how we manage the processes, manage the projects, and then we are going to continue with BIM, the importance of BIM in project management. So let's start with some definitions, formal definitions. We use projects and project a lot in our daily lives, but what is the formal definition of a project? It can be defined as a temporary endeavor undertaken to create a unique product, service, or result. The temporary nature of a project indicates that it has a definite start and finish. It creates something new. It could be tangible, intangible, or both, and it starts with an idea. And moreover, it is different from business as usual and operations. And here we can see some examples of projects, also from our industry, engineering, construction, and architectural industry. Could be constructing a building or infrastructure. This could be an office building or a railway project, or developing a new part, a cross rail for the existing projects. Merging two organizations, improving a business process within an organization, exploring for oil in a region, even conducting a research to develop a new manufacturing process. And we need to manage these projects. Then we come to the question, what's project management? Here I would like to share a small video. Let's watch it first.
Life is full of projects, whether it's something you do at home or something you do at work. And one of the skills students will need in order to complete projects is project management. But what exactly is project management? Well, project management begins with goal setting based on the big picture idea of what you want to accomplish. Here you need to have a clear sense of where you are going and what it will look like when you are finished. It also involves breaking the project down into tasks and subtasks with clear deadlines. Here, you often visualize each part of the task, creating a bridge between the abstract ideas and concrete actions you will take. And in this phase, you also develop a plan of action and select your tools and materials. And if you're working collaboratively, you often divide up the roles and responsibilities. Next, you choose and implement specific strategies. And as this occurs, you begin to monitor your progress. You'll likely run into barriers which will force you to problem solve and experiment. You might even need to pivot and re-examine your original goals. Now, when students learn the project management process, they grow into self-directed learners capable of being self-starters and self-managers.
So, we can define the project management as the application of knowledge, skills, tools, and techniques to project activities in order to meet the project requirements. Project management can be achieved through the suitable applications and integration of the project management processes. It enables the organizations to execute their projects in a more effective and efficient way. And here we can see the project management triangle, which is a model of the constraints, including cost, scope, and time. So this is the project management, triple constraints of project management, and the success of a project depends on its completion on time, within the budget, and according to the specification, which is based on the scope of the project and the desired quality, as well as the degree of customer satisfaction. And here I would like to highlight the importance of project management by comparing effective project management and poor project management or without any project management, what we encounter or what we gain. So if you apply project management effectively into your projects, you can meet business objectives, be more predictable, resolve problems and issues, respond to the risks in a timely manner, manage the constraints in a better way, managing the change in a better manner as well. But when we don't talk about any project management or poor project management, we can encounter missed deadlines, cost overruns, poor quality, rework, and unsatisfied stakeholders. And a project lifecycle is divided into 5 main phases, including initiation, planning, executing, monitoring, and closing. In the first phase, initiation phase, we should define the project and set up expectations. In the planning phase, we create a plan with the schedules, the program, on which time frame we are going to implement our project, the tasks, resources, and the budget. Then in the execution phase, we start to implement the project plan. In the monitoring, we control the execution if it is in line with the project plan or not. And in the closing phase, after reaching the project goal, we compile all the documents and reports. And here we can say that the project process can often go back and forth between planning, executing, and monitoring phases. And here we can see a small figure which tells that each phase has lots of smaller sub-processes, and it has inputs and produced outputs. And during this transformation process, we can apply project management tools. These could be some document templates or some diagrams or some other techniques and methods. Even it could be a software. And in the project management, we have 10 knowledge areas, including time management, cost management, scope management, risk management, integration management, integration of all these, risk management, stakeholder management, procurement management, and project managers need to master these knowledge areas to successfully implement their projects. So these are important facts of project management, and I would like to continue with some basic concepts. These can be also the project management tools that we use in the related phase. So the project charter is a document, and it is the statement of scope, objectives, and people who are participating in a project. It is typically short and a formal document, and it is created at the very beginning of your project. So it is in the initiation phase. It should be simple, straightforward, short, but also it should contain key elements. And these key elements include the project information, rationale for the project scope, and if there are any limitations for your project, those limitations, the project objectives and goals, the participants and their roles and responsibilities, possible risks. At the beginning, it is really useful to identify the possible risk that you may encounter and approval requirements. The other concept is VBS, or work breakdown structure, which is a hierarchical decomposition of the total scope of your work. It is breaking down your project into smaller pieces. So here you can see a very simple example, building a house. For example, you can have layers or levels. So in the first level, you break down your work building a house into design, structural, utilities, and finishing. Then under the design, you need to do some other steps. So deciding on plans and making changes to those plans. So we can also call these as work package. So this can be sub-work package, and they may include other activities or tasks, we can say. So it is making your project breaking down into smaller pieces and manage the project in an effective way, because for each work package or activity, the responsible team will be different, and their working techniques could be different. So it is better to make it into manageable pieces. Another concept is milestone. We can define a milestone as a significant point or event in a project, and they have zero duration, because in your project, for all your activities, you have some duration, as we can see here, but for milestones, they have zero duration because they are significant points or events in your project. They could be at the end of a phase or a process, in the middle of it, and even they can be a decision, a question you may ask. And when you integrate these milestones into your schedule, you can manage your project according to these. So it is good to integrate these milestones into your schedule. So we mentioned a little bit about project management. Now let's talk about the current or predominant business models in the industry, in order to better understand what BIM introduces into our industry. So project delivery process has been fragmented and dependent on communication using 2D drawings and 3D CAD tools. And when you consider the environment of a construction project, we talk about a large number of people, participants of the project, and documents that are produced by these participants. And with 2D communication, it is really not easy to manage all these people and documents. And when we say the participants, we mean we have three principal contracting parties: the owner, the design, and the contractor. So the owner makes the decisions. The designer performs, develops the contractor documents, and the contractor is responsible for the work on the construction site so that they could deliver the constructed projects. And all these activities are known collectively as project delivery. And project delivery method describes how these participants are organized to work within a contractual relationship. So now we are going to see the project delivery methods, common project delivery methods. There are three common project delivery methods. The first one is traditional design, bid build. Traditional, or sometimes design bid build. It's the same. Second one is design build, and third one is construction management, and it has two different models. One is construction manager as agent, the other is construction manager at risk. So in the traditional one, owner hires a designer, and after the design phase completed by the designer, because they also create the contract documents, and it's also called tender documents, they prepare them, then the owner goes to the tender stage. And for the tender stage, general contractors offer their bids, and the owner selects one of these contractors. And after that point, the general contractor starts to work on the construction site. So the phases, the design, the tender, and the construction phases are followed by each other. In the second project delivery method, in the design build method, the owner this time hires a design build company. So the design build company is responsible for both designing the project and constructing it. And the contractor can directly communicate with the designer from the beginning of the project. And this feature of this method provides fast track method, which I am going to explain shortly. Then in the third project delivery method, construction management, in the first model, the construction manager acts as an advisor for the owner from the beginning of the project. And this can provide lots of advantages to the owner and for the project success, because construction manager knows all of the processes regarding the project, construction project. And when we consider that generally owners or investors for construction projects, they are not from the field and they are not really familiar with construction processes. So it can have lots of benefits to the owner and to the success of the project. And in the construction manager at risk method, this time construction manager again at the beginning of the project acts as an advisor for the owner, and later they become as a contractor. That's why they are at risk, because they are responsible for the construction as well. And here also we can see the contractor can communicate with the designer from the early stages of the project. And fast tracking, as I mentioned, fast tracking and project means the activities are worked on simultaneously instead of waiting for each piece to be completed separately. In the traditional method, we can say the phases or activities have finish to start relationship. So you cannot start any activity or phase before the previous phase is completed totally. So it has a traditional method and finish to start relationship. And in the fast track method, since contractor can involve into the project in early stages, they can have start-to-start relationship between the phases and activities, and this can reduce time. So we can save time, construction time could be decreased. So this is the method. And as a fourth and relatively new procurement process, integrated project delivery, or in short IPD, is distinguished by early collaboration between cross-functional terms through all phases of a project. The key benefit of this method is reduced time and cost through collaborative teamwork, and shared objectives and consensus in decision making are the main hallmarks of an IPD project, we can say. Here again, I would like to show you a small but very nice video regarding the difference between traditional and integrated. So let's watch it.
In North America, small and large building and construction projects alike often do not finish on time or on budget. In the United States, for example, delays and cost overruns affect nearly 1 in every 3 projects. But there is a better way to approach design and construction that can save resources, time, and money. It can also improve the quality, comfort, and environmental profile of a building during its entire life cycle. The idea is to involve the project team in all stages of a construction project, from design to delivery. To understand the advantages, let's look at the traditional design, bid, and build approach. Here, an architect designs a building with expert input. Then, contractors bid for the opportunity to build it. The successful bidder oversees the construction, and building operators manage it. But this conventional assembly line approach can have plenty of hidden problems. For one, conceptual or design flaws can become apparent during the construction phase. Fixing those mistakes can derail the production schedule and add to costs. Under serious financial pressure, a project may fall short of its original goals on performance and sustainability. Now, consider a more integrated design and delivery approach. Here, the client, the design team, the construction professionals, and the building operator collaborate from conception to completion of the project. Ideally, even before the design stage, these key stakeholders agree on shared values and goals and technical specifications for the project. They develop a common business model and perhaps even a common contract structure in which they all share both responsibility and reward for success. The result is a project that is likely to run more smoothly, be more efficient and profitable, and have a lower impact on the environment. You too can help build efficient, healthy, and sustainable buildings for our communities in North America and our planet. Learn more about integrated design and delivery by visiting the Commission for
So this graph also explains or shows the differences between traditional and integrated approaches from the questions, some questions. What are these questions? What, how, and who? So in the traditional method, the question what and what is going to be constructed can be discussed until the middle of the construction phase, we can see from the graph, because there can be lots of changes. Then the how is not determined, how is going to be constructed is not determined until the end of design development phase, and who is selected at the tender phase. And when we check the integrated approach, since the early collaboration of main participants, main project teams, most of the what is decided before the implementing construction documents. So this minimizes the possible changes for construction phase. Then who is going to undertake the processes is also planned and programmed at the early stages and quite early before the construction phase. And similarly, the how is going to be constructed is also discussed during the design phases. So all these collaboration minimizes the possible changes and cost overruns, and this can reduce in reduced construction time. And what is the importance of BIM in integrated project delivery? Through early collaboration and the use of BIM technology, a more integrated, interactive, and virtual approach to building design, construction, and operation is emerging. I would like to clarify that IPD, Integrated Project Delivery, and BIM are different concepts. Certainly, integrated projects can be done without BIM and vice versa. So they complete each other. However, the full potential benefits of both can be achieved only when they are used together. So what is BIM then? As a modeling technology and associated set of processes to produce, communicate, and analyze building models, we can define BIM as shared digital representation of physical and functional characteristics of any built object, which forms a reliable basis for decisions. So you have your project digitally in the digital environment before it is constructed on construction site. It is the representative of your real project in the digital environment. And NBIMS categorizes BIM three ways. As a product, in this case, it is building information model. As a process, in this case, it is the building information modeling. And as a system, this time we mention it is building information management. And from the project management perspective, BIM is a new type of message. It is the communication factor, and it is the process of communicating by transmitting the message encoded in the form of building information model from the sending system to the receiving system through the computer network. Another way to categorize BIM is to define the progression levels of maturity. In this view, BIM is seen as a series of distinct stages in a long journey, we can say, which started with CAD and is taking the industry into the digital age. So the first level is called level 0, and we can define it as unmanaged CAD. And here we talk about drawings, lines, arcs, and text, etc. It is unmanaged CAD, we can call, and the majority of industry is well ahead of this level. In the second level, which is level 1, it can be called as managed CAD. We here create our projects mostly with 2D drawings, like 2D drawings, and we use 3D models generally for the purposes of 3D visualizations. That's why we talk about some standards, and we can say it is managed CAD. And this is the level most of the companies are operating now. Then level 2 BIM, we can call it as an managed 3D environment. Here we start to talk about objects and collaboration. And this collaboration comes in the form of how the information can be exchanged between different parties. And when we say exchange of information, we are talking about some standards, some standard data models, which I am going to explain also. And in the level 3, it is the full collaboration and full integration by means of a single shared model. All parties can access and modify this model, and this provides lots of advantages, minimizes the risk, conflicts, etc. And this is called also Open BIM. And moving up through the levels of technology use leads to seamless working and effective data and process management. So what are the features of BIM? Let's talk about them. The first one, it is an object-oriented technology. Differently from 2D, now we approach the buildings as the composition of building elements or components. So in CAD environment, we use the line arcs and rectangles and create our projects. If we need to add some non-geometrical information, we just use the task on the same file or different files, but they are not integrated. And we create two parallel lines, for example, and we call that is a wall. But it is just because we call it as a wall, it doesn't know itself as a wall or behave like a wall. But in the BIM environment, since we are working with representative of real objects, we are using wall object, for example, or wall component, we can say, because it has subcomponents. When you design, you also need to think the core element of the wall, the insulation, and the coating or finishing of the walls. So it is like a component and including subcomponents. So except from the geometry, you can add other information, which is material, color, etc. You can all add those features or parameters into your components or building elements. So it works with the BIM objects. And parametric objects is the central to understand BIM and its differentiation from the traditional 2D. So the parametric objects, the objects in the BIM environment, are defined as parameters and relations with other objects. And if a related object is modified, the other associated objects are also automatically changed. So, for example, a plan and elevation of a given object must always be consistent. Dimensions cannot be fudged. Or when a new object is inserted into a building model, or when changes are made to associated objects. Another important thing here, since we store all the data in a central file, if anything changes in your model, it automatically applies in the other views. For example, here we can see, for example, if you want to change something regarding this door, it automatically changes the door and wall associated and also floor objects, all associated objects. And it is also rule-based technology. We can say there are some certain rules. For example, we cannot insert a window onto a wall or onto a floor, sorry. It is only allowed for possible other objects. So you cannot insert a window onto a floor, but you can insert, or for some dimensions, you may not be able to, for example, create a door with less than 50 centimeters, for example, because it wouldn't be functional. So you can work in one view, but when you add something or change anything, it automatically applies into the 3D model, the elevation or other related parts, and even the schedule, because it automatically creates the schedule, the quantity of your spaces. So this is the bidirectional associativity feature of BIM. So we can say they are information-rich models. We have the 3D geometry, but we can enter and link other information. The material, the cost, the energy related data, anything. So you can also extend these parameters in the BIM software. Also, BIM serves as a platform for creation and management of the information about the building through the entire life cycle of the building, including design, construction, operation and maintenance, and even demolition. So since we can add lots of parameters and information into our models. So it is all about exchange and sharing the information among the project participants. And how we are going to do this exchange of the information. And here we start to talk about interoperability. So BIM provides the exchange and interoperability of information through IFC or Industry Foundation classes, which is developed by Building Smart for BIM. It is the home of BIM, we can say. Interoperability is the ability to exchange data between applications to provide more effective collaboration. So let's look at the IFC. What's IFC? Very briefly. It is a global standard used to describe, share, and exchange information. The data format is neutral and it is open file format, and it can be supported by more than 100 software applications. So here I would like to clarify, BIM is not a software. So sometimes you may hear like what is BIM, everybody says Revit, but there are BIM software or applications or tools which are based on IFC data standard. They should developed by using the IFC standard, otherwise they are not BIM. And these applications can be used. And for example, the architectural discipline can use Revit. The Tekla is used by the structural discipline. Then the mechanical and engineering team can use another BIM software. But when they want to coordinate and federate their models together, they may use a software called Navisworks, which is good for that, which is developed for that purpose. They may all export their BIM models as IFC files, so that the Navisworks software can open all their projects and shows these IFC files as a 3D model. So we can see here lots for different purposes. We can see different software from design authoring, data management, collaboration, for environmental purposes like doing the energy analysis or for clash detection, for visualization, for fabrication. These are all IFC supported BIM applications or BIM tools or BIM software, we can say. And here we can see lots of BIM uses, from 3D coordination to energy analysis, structural analysis, to scheduling, for cost, etc. Which I'm now going to mention because it goes beyond 3D. So we have the 3D model and we have the smart objects because they behave like a column. This column knows that it's a column and behaves like that. So how much will it cost? We need also that information. How much time will you need to build this column or this section of your project? How will you maintain it? Is it going to be energy efficient or not? So you may have some sustainability concerns, and you may maybe want to get a certification, green building certification. So then you need to talk about the think about the sustainability issues. So from design to cost to time aspects, we can enter and should enter lots of information onto our 3D model. So here I would like to show you a small video regarding 4D, which is time or schedule. These are the dimensions of BIM, we can say. We add time-related information on our 3D models to different components of information model. It is used to develop an accurate project program showing how the project will develop sequentially and how it visually appear at each stage. It helps that you can see in the digital environment section a small fraction of your construction on the construction side. So it avoids, provide avoiding delays and surprises on the construction site, because before you can easily check and assign time-related information onto your 3D models. Then we have the cost information, and this time it is called 5D, 5 dimension, which is cost estimation. We linked the cost data in order to support cost planning and generate cost estimation. Then also we have the 6D, which is operation and maintenance. After you complete your project on the construction site, now it is the phase for the usage. So this means operation and maintenance, especially when you think about really complex projects like hospital or airport, etc., or even a railway. The operation and maintenance phase is really important for those projects. So facility management, you can have the related information regarding facility management, and you can better facilitate, operate, and maintenance your projects. So what are the benefits of BIM then? Let's talk about that. We can say the first one is improved collaboration and communication, because the BIM enables better teamwork. So the information-centric model takes the place of document-centric model. So it changes the way how we design, construct, and facility manage the projects, and how we communicate each other. So we can achieve better collaboration and communication. Also, it provides accurate 3D project visualizations, even for complex and really complicated structures. At any stage of your project, if you start to create your projects in the BIM environment from the early stage, at any stage, you can have accurate 3D visualizations. It increases the building performance and quality through the early evaluation, because there are lots of tools or small software packages that you can use and integrate with your BIM model to see the energy analysis and other structural analysis. And during the design phase, when you apply and do these as your project progress, at the end you can design a better building, and after the construction you will have increased building performance and quality. Fourth, we can say we can reach reliable and more accurate cost estimations, because the cost assessment is based on models, and it automatically gives the quantities of your elements, and it prevents the human error, because normally manually a person does these calculations, and it is really open to errors. But with these automatic processes, we minimize that, and we can have more reliable cost estimations. And as we mentioned, since we can add the time related information into our 3D models, we can have superior scheduling. Another and very useful benefit is effective clash detection and coordination. So before the construction, before we start the construction phase, in the design part, we have the architectural team, we have the structural team, and we have the mechanical team, and they create their own projects. And before the construction, you need to federate or coordinate, or sometimes we use superpose. We superpose all these projects. And when you superpose and federate them, you can see is there any conflict or clashes happening. With the 2D, it is all, for example, for the first level floor, you need to put all the architectural, engineering, and mechanical all together, and you need to check each level. And besides, you need to check the sections. But with this 3D model, you can federate all, and you can have one model. And you can even closely check. Here, for example, we can see there are lots of clashes happening. These are the mechanical channels going through the structural elements, which cannot be possible. So before the construction, it should be solved. So these issues are forwarded to the related parties, so they can do the modification and any changes, etc., which really prevents lots of time regarding the design processes, as well as the construction time, because it happens before the construction starts. And this is called hard clash, we can say. With BIM, also, if you assign some rules, you can detect soft clashes. What do we mean by soft clash? It means, for example, this channel may need some space around it. So, for example, you may need at least 50 centimeters for repair or maintenance purposes after the construction is completed. If it has like 30 centimeters, the program warns you so that it can also detect those kind of soft clashes, as well as hard clashes. Hard clashes are easier to detect, but those kind of soft clashes may not be easier even with 3D or models. So it really saves a lot. Other benefits, we can say, BIM also facilitates prefabrication, off-site manufacturing processes, and increased productivity by reducing the rework, the waste, and delays in general. So it increased the overall productivity. And since you can discover the design errors and omissions on time before the construction, it can reduce the project time and cost, because if you spend more time, it will result in more cost. So they are very related. Then, as also we a little bit mentioned, but I can repeat here again, it provides stronger facility management and building handover, because after you finish the construction of your project, for the operation and maintenance phase, you may still need information to manage your facilities. So if you provide the collected information from the design and construction phases for the building systems, you know, for example, the purchase date of a system or other information, necessary information, even the zones, etc. So you can get the related data from your database, and you can use the information for management purposes, and it will provide seamless workflow processes for the facility management. So we now aware about what BIM exactly signifies for the industry. However, due to the nature of our industry, architectural, engineering, and construction industry, we have some really distinct characteristics, and it is not really easy to adapt technology. And when compared to the other industries, the technology adoption level is quite low. And we can say that the resistance to change can be the most and first excuse or reason to this. Because we have, in the industry, we have lots of participants, including the top management to the operational levels. So in the operational level, you have the workers even on the construction site. When you decide to use a new technology, it should embrace the all participants of the industry. Since our industry is really fragmented, it is really difficult. So this can be the one of the reasons. And the other could be the cost investments, because these are expensive technologies. You need to invest in hardware and software, as well as you need to invest into the staff training, because they need to learn these technologies as well. So these are the main problems for successful BIM adoption, we can say. However, for today's competitive construction business environment, we should also, on the other side, we should also overcome these problems. To do that, it is better to understand the factors affecting successful BIM adoption. And we can say people, technology, and process. So the old mindset should change to new mindset. The overall mindset of the participants should change. They should change the mindset. You may encounter, after you graduate, you may encounter this resistance. Then with the integration of technology and process, we leave our 2D or paper documents approach, and we adopt 3D presentation and digital documentation. And with the new approach, it comes from separated entity to collaborative work environment, and it also provides continuous communication instead of communication breakdown. So it is really important to face also these encounters after knowing the benefits, but it is also not easy. Also, I would like to add, this is also political, because the government should also have some policies and regulations which can really accelerate the pace of BIM adoption. So it's like a whole system. Okay, yeah. Thank you very much. Thank you for listening.
The attendees, if they have any questions, they can write on the chat box, and I can direct the questions. So you can write the questions on the chat box. But I have a question. How do you think this COVID-19 pandemic period that we're going through is going to affect the use of BIM?
Yeah, it's a very updated question, and actually already COVID-19 definitely highlighted that a lot of work which can be done in the industry, on construction sites or in the offices can be done remotely with ease. But beyond that, I would like to highlight that the BIM and its integration with other advanced technologies like digital twins or IoT, Internet of Things, or GIS systems, geographical information systems, they can help mitigate the risk of COVID infection in the workplaces and on the construction sites. So we can say it can play an active role in the health and safety for our industry, which is also very an important issue, and especially with the COVID pandemic. So they are starting to integrate these technologies into the processes, and especially to prevent the infection. So they are already being discussed, and especially with the integration with other technologies. So BIM is a very useful tool. Okay, we accept that, but also there are other advanced technologies, digital technologies in the industry. We can get the maximum benefit with integrating those technologies also. And it is easy if you have your models, both design and construction, for design and construction, but especially after the construction, the as-built projects. If you have them in as BIM models and with the information, necessary information, it will be really easy to integrate.
Thank you. Most of the students here are students that are taking environmental control systems, the class, this semester. And what we have been doing this semester, especially towards the end of the semester, is we were trying to put together a ceiling plan to show different systems, such as a ventilation system, HVAC system, and electrical system, lighting system, fire system, and they were all coming together, and they should not be clashing. They should not be overlapping. And you showed that in the benefits of BIM section. You said effective clash detection and coordination. You talked about hard clash, where like a duct, like an HVAC duct would go through a column, a beam, something, the structural element, and it's not possible. The program or BIM programs, they prevent it. And if you set the rules right, you could also prevent soft clashes. You could leave enough space around each of the objects. So that's a very good idea for our classes, which that's what we try to do in the class. So that was that was quite fun for me. And also, as architects, we don't really talk about what happens after the construction. Like we always talk about the design and we talk about the construction, but we usually don't talk about what happens when the users, they get in and start using. But like they have to manage all of the systems. They have to manage at least heating minimally or lighting. but also other systems like security systems, electrical systems, cooling systems, all of the different systems. They cost money, energy, and with BIM, I think it helps the post-construction phase when we use.
Yeah, exactly, exactly. It's really like, because when you consider a building life cycle, so you can finish the design phase in 1 year or 2 years maximum, depending on the size of the project. Then the construction, again, you may finish it within 3 or 5 years. And when it comes to the usage phase, it may take 50 years minimum, especially for when we talk about a railway project or an airport or hospitals. So it can be up to 100 years. So that is actually the most cost and other things happening in that phase. So it is really important, and we should really focus on that. We should design and construct thinking that phases as well, because it is really difficult later if we want to make changes. It means time and cost. So nobody wouldn't want that. So it is better to design for disassembly. That's a term, like design for disassembly. You should also think the disassembly, how you are going to demolish this project, because it shouldn't also affect the environment badly. So nowadays it is all discussed, like the circular economy, the sustainability impacts of construction, because construction industry is unfortunately one of the worst industries affecting our environment also. So there is also another term like begin with the end in mind. So you should begin to think and consider first thinking the end, like what's going to happen, what will happen. So it's a really important aspect. Design for disassembly and design for thinking the facility management phase also. And yeah, of course, BIM provides easier facility management, because you can store, put your data, related data and information for the facilities. It could be a good tool, but yeah, it is just a start. You may start with small projects, but later, after you graduate, because also at our educational system as architects, you just only consider the architectural part of the projects. But when you graduated, you work with other participants. You need to work with the structural engineers and mechanical engineers. So you need to coordinate and federate your projects. So, but you can start with your architectural projects at school, so that after the graduation you can say, I know BIM, or I can use at least one BIM tool. Once you know how to use one, you can easily adapt the others.
I received a question. I think this question is a very nice question, especially for you, because you've worked in different countries. The question is, how do you evaluate the use of BIM technologies in Turkey compared to other countries? Is it becoming widespread as it should be or not?
Yeah, unfortunately, we are a little bit behind because of it affects lots of like there are other factors, unfortunately. I know from the industry there are really good companies, both architectural offices or contractor firms that they are applying BIM in their processes. But when I invite them into our classes also, the first thing they say is there is a really resistance to change. Nobody wants to change and leave their traditional methods. And also unfortunately in Turkey, the regulations and some other aspects that you cannot really interfere may prevent the adoption of BIM on top of the other reasons. And for example, I can say in the USA, it's really because especially after the Autodesk Revit, that's why due to the market share of Autodesk Revit in the USA, it started really quickly. But recently, the UK, we can say, are a little bit ahead of them, because in 2019 they made it as a mandate. So for all public government public projects, you need to submit BIM projects, and they said that it should be level 2 BIM. So all parties, if you are running a government project, public project, it should be BIM. That's why at the end I also wanted to focus on that. With government regulations, without them, it is not really easy, even in developed countries. But with these kind of regulations, or for example, Singapore is also very, very ahead of this level, because they, for the tender process, until recently, they had a limitation, like up to this size of projects should be uploaded into the e-submission with BIM. But later, recently, they changed it to all projects, including both private and public projects. So they should apply or create and apply to the municipalities to get the permission of their projects. They should apply into the e-submission, and everything can be done automatically. And with BIM tools, if they also have the standards, that is another aspect. If we don't have a national standard or adopt a standard, BIM standards, it is also not easy. So I can say we are a little bit, it is getting better. I don't want to be very pessimistic, but also it really depends on the industry and the participants and the new generation, the new graduates like you. If you are also trying to adopt these technologies, it will be a lot easier. And because some of the BIM companies say we can't find any staff
yes.
that knows BIM, so how it is our struggle, they say. And in Turkey, another thing for the contractor companies who operate in Middle East or Russia, who works with internationally, due to the contract requirements or the owner requirement, they had to adapt these technologies. But for Turkey also, there is another good thing for the municipality, the Istanbul municipality. They said in Istanbul, this is only for Istanbul, but the railway projects should be submitted and processed through BIM. So for example, the new project, Mahmut Bey Kabataş Beşiktaş project was developed using BIM. But they had lots of difficulties and problems due to the processes, because they were saying like all people, like working people, may not be engaged quickly as everybody, so they had problems. But it is a rule that the railway projects should be done through BIM. So we can say it's happening, it's not bad, but when we mention about the theoretical part, theory of BIM, it seems like as a magic wand, and it is very easy and thing, but it takes effort and to get the benefit.
Good adaptation techniques.
Yeah, exactly. So, but yeah, it was a good question. Thank you.
There was also a follow-up question, but I think you answered it partially. They asked if we use BIM in public buildings in Turkey. So you gave the metro example, but probably there are not so many examples.
Yeah, it really depends on the regulations, since it is just valid for Istanbul and for railway projects. So the government, like the public government, should say all public projects. So this could include the housing or the dormitories or the schools, like elementary schools or anything, universities, like including all public projects. And for that, they need to initiate some standards. But there are initiations and forums you can follow. For example, also there are lots of events happening. I can maybe write to chat if that's okay.
Yes.
BIM for Turkey, for example, this is also founded by students. Some students who are really interested in BIM approach. So they create some events, and they had their last event online. Normally it is physical events, but they also started to do it online. So they invite experts, different people. Sometimes they discuss with the professors or head of the departments for the universities and for the education, but sometimes they can also have other advanced technologies from the industry worldwide. They can find, especially Turkish citizens who are working in abroad, so they can find, or BIM Genius. This is also another it's like this. So you can follow these kind of groups, and you can and for more detailed, you can follow the Building Smart, but it could be a little bit technical.
But these two are great. Thank you. Okay, I don't think we have any more questions, and it's been a long talk. We've been like 75 minutes. So thank you for joining us.
Okay, thank you a lot for the invitation.
Thank you for all the information that you gave.
I hope it was useful, and
yes, thank you.
Yeah, thanks
and
a lot.
Thank you for everybody who joined and listened. But we'll see you in other events.
Yeah, hope so.
Thank you. Bye.
Thank you. Bye bye. Bye everybody.